This is 7.5b as in boy in trigonometry, applications of vectors, and we are on example number 3. So we have a force of 16 pounds required to hold this 40-pound lawnmower. So if we've got this little lawnmower sitting on here, come on, let's draw my little lawnmower. Okay, bad lawnmower. Alright, so we've got our lawnmower right here, and it weighs 40 pounds. So it's got 40 pounds going straight down, therefore that 40 is there. And we know that in order to hold that from sliding down that incline, we have to pull with 16 pounds of force. So BE is our magnitude in order to make sure this doesn't go anywhere. And it's kind of like our equilibrant, because this wants to go that way. How much force this way are we going to have to do to keep it there? So AC is also 16, because we've got if you draw this, you're always going to have a parallelogram. Why is this not drawing? There we go. So the length of this and the length of that are going to be the same. Okay, let's get rid of my lawnmower there. Alright, come on, let's move this stuff back. So we're going to draw this triangle right here, just because it's going to be easier to find the parts to this triangle. So what we're looking at is, notice this angle here is going to be the same as this angle, and that's what we're looking for. So you could actually write this as theta right there too. Okay, so that's what we're looking for. We're given a side, and we're trying to find this angle right there. Alright. So what are we going to use in order to do that? We are just going to use, again, go back to section 2.1, and we know to find that angle, we're going to take the sine of theta, and that's going to be opposite over hypotenuse. Okay? And so 16 over 40 is going to be 0.4. So sine of theta equals 0.4. And then if we take the arc sine of 0.4, we will get our angle, and that's going to be around 24-ish degrees there. And that's it for that one. Alright, so last example will be example 4. We're not going to do example 5. I didn't give you any homework on it. And so you should be good to that. Let me get rid of this and put the next drawing on here. Okay, so with this diagram, they almost gave you the answer. They gave you so much information. So we've got a port, and that port is right here, point P. And a ship leaves on a bearing of 28 degrees. So it's following this blue line right here. Once it goes 8.2 miles, it says, it turns east and travels 4.3 miles. We're interested in how far it is from here to here, and again, what angle is that ship from the port? So this was 28, but we want to find out this angle right there. So we're looking for that, alpha, and we're also looking for this length, PE, and again, it's in the absolute value signs because it's a positive, it's magnitude. Okay, so let's see what we've got here. We know that this angle here is 118, and we're going to need that because this is the triangle that we're going to be looking at. So we need more than just this length and this length. We are going to need an angle. And they've given us that 118. It is not in the story problem, but they got it because this is a 90-degree angle. This is a 28-degree angle, which means this has to be a 62-degree angle. And 62 from 180 gives us 118 right here. So that's where that came from. So if we're looking for PE, that's going to equal 8.2 squared plus 4.3 squared plus 2 times 8.2 times 4.3 4.3, my decimal kind of disappeared there, 4.3 cosine of 118. So that gives me my magnitude of PE to be around 11-ish miles. So the distance between here and here is going to be about 11 miles. The other thing I'm looking for is this right here. So I'm going to find this angle and add 28 to it, and that'll give me the angle they want. So this angle right here, again, I'm going to use the law of sines. And the law of sines says that the sine of, what are we going to call that, APE over APE, the opposite, would be a 4.30, and that's going to be equal to the sine of my other angle over, let's see, the opposite of 118 will be my 11 that I just found, my hypotenuse there. I do my cross multiplication and I get my APE, this angle right here, and that's going to be equal to 20.4. And if I add 28 to that, I'm going to get this whole angle here. So I'm going to get somewhere around 48.4-ish for my angle. And that's it. When again, we're not going to do example 5. I didn't give you any of those problems, so you should be good.